Hello, student of class 11 science, thermodynamics we are going to discuss. It's a very cold and chilly winter, and in this particular chapter, we are going to discuss the thermodynamic variables, different systems, thermodynamic processes, and the relation between Cp and Cv, isothermal process, adiabatic process, the equations of isothermal and adiabatic, plus the work done in isothermal and adiabatic process. Okay, now let us see thermodynamics part 1. First is your fundamentals. That's important. What is the meaning of thermodynamics? The study of heat, temperature, and conversion of the mechanical work into heat and vice versa is the thermodynamics. Study of heat, temperature, and conversion of mechanical work into heat and vice versa. Next, there is macroscopic thermodynamic coordinates or variables. Other name of coordinate is variables. What are the thermodynamic variables or the coordinate? Pressure, volume, temperature, entropy and enthalpy. Pressure, no, you know. Volume also, you know. Temperature also, you know. There are two important terms, entropy and enthalpy. Entropy means disorderness of the gases in a chamber or a system. Disorderness. And enthalpy means the sum of internal energy and the work done. Work done, P into dV. Work done. Sum of the enthalpy is the sum of the internal energy and the work done is your enthalpy. However, in this particular chapter, we are going to use this your pressure, volume, and temperature. That's the 90 to 95% places we are using this only. Then comes the thermodynamic system, a collection of an extremely large number of atoms or molecules confined within certain boundaries such that it has a certain values of pressure, volume and temperature is called thermodynamic system. Like for example, one thermodynamic system, one gas chamber is there, or a piston, having the piston. So whatever the initial condition is there, whatever the initial condition means of the gas, pressure, certain value of the pressure, volume and temperature, then we are going to say this is a thermodynamic system. So any certain value of the gas, pressure, temperature and the volume, some value, that is a certain you can say thermodynamic system. So that collection of the extremely large number of gas in a particular enclosed chamber is a thermodynamic system. Then comes to the open system. What is the meaning of the open system? If a particular system, if it can exchange both energy and the matter, with its surroundings, then that system is known as the open system. A system which can exchange both energy and the matter with its surroundings is known as the open system. Another is your closed system. If a particular system which can exchange only energy, not the matter, with its surrounding, only energy exchange but not the matter, then it is known as a closed system. Isolated system. Remember, if a system which can neither exchange energy nor matter with its surrounding, ना तो exchange energy का होता है ना matter का, किसमें? Surrounding से, then this particular system is known as the isolated system. It can neither exchange energy nor matter with its surrounding is known as the isothermal system. Thermal equilibrium. Two bodies or thermodynamic system in contact are said to be in thermal equilibrium if both are at the same temperature. That means the variables or coordinates like P, V, T and number of particles etc. do not change with time. Whatever the value of P is there, whatever value of T is there, what V is there and whatever value of T, that remains same, or N, number of particle. It remains same. That means if a system is in contact with the another system, here one system, here B system, another system B, these two are in contact. If the temperature of the first system is equal to temperature of the second system, then at least the first condition, the temperature remains same, then we are going to say it is in thermal equilibrium. In other words, if you are going to expand it, then you have to say the pressure, volume, temperature and the number of particles are same in both the system, then we are going to say these two are in thermal equilibrium, right? Then comes the Zeroth Law of Thermodynamics. Here, just to see the diagram, I have taken here the three thermodynamic system A, B and C. A is the first thermodynamic system, B is the second thermodynamic system, C is the another third thermodynamic system. A and B are separated by adiabatic wall, means non-conducting wall. And B and C plus and B and C, A and C and B and C both are separated by a dithermic wall, that is conducting wall. ये तो कंडक्ट करता है ये वाला वॉल, लेकिन ये कंडक्ट नहीं करता है, नॉन कंडक्टिंग. तो अकॉर्डिंग टू दिस Zeroth law, if system A is in thermal equilibrium with C, thermal equilibrium, we are going to say that means temperature of the first one, A, is equal to temperature of C. If A is in thermal equilibrium with C and separately B is also in the thermal equilibrium with C, then A and B both are in thermal equilibrium. So how we are going to denote it? If temperature of A system is equal to temperature of C and temperature of B is equal to temperature of C, then temperature of A is equal to temperature of B, means both are in thermal equilibrium. If TA is equal to TB. So that is the zeroth law, the very simplest law. TA is equal to TC, means A and C are in thermal equilibrium and B and C are also in thermal equilibrium, then A and B are also in the thermal equilibrium. This having a non-conducting wall in between A and B. That is the Zeroth law of thermodynamics. Work done in gas. Actually, what is the exact meaning in the work done in gas? Say one chamber I have taken in which gases are there. Gas is there, and having the pistons fitted, and then we are heating it. And this gas is having the thermodynamic coordinate P, V and T. Pressure of the gas is P and volume of the gas is V, temperature is T. Now just after heating for some time, what happens? The gases will strike onto the piston, giving the extra pressure thrust, and then what happens? This piston will move. After getting the thrust, piston will move somewhere here and it displaces at a distance, say the dx distance, it expands dx distance. Then we know we are going to find the work done. For the small work done, dW, work done is what? F dot ds, yeah, dx. That is the work we know. And the pressure means as the pressure is there, and I am going to assume the cross section area is A. A is what? Cross section area of the piston. So if P is the pressure, exerted by the gaseous molecule onto the piston, and that is equal to force by area. So force is equal to P into A. And second point is that, so the force is acting in this way, and displacement is also occurs in the same way, same direction. So as the angle is 0, so we are removing this cos 0 1. So ultimately F into dx. F is the, in place of F I am putting P into A into dx. What is this A into dx? A into dx. A is the area of cross section, and dx. So A into dx is that particular volume, area of cross section into that particular distance. So the small volume. So we are going to write dw is equal to P into dv. That is your work done, P into dv. So this is the small work done. That is equal to P into dv. Total work done, if you are going to find out total work done, what you have to do? Integrate dw is equal to integration P dv. Say here V initial to V final. So ultimately what will happen? P into V, integration of V, dv is V, Vi to Vf. So we can write dw integration is w, and here P within bracket upper limit Vf minus Vi. That is the total work done. Right? This is the way how to find the work done. Simple. So wherever the dw or the work done is there, Pdv, dw, Pdv, dw, Pdv. Okay?